Hi everybody, this is Amdur Srinivas. This video deals with introduction to the signals, and in this topic here we have to discuss the basic definition of the signals and how to perform operations on signals and types of the signals. These three topics we have to discuss in this. First we'll go through the definition. The definition of signal is which conveys the information, or which passes the message to the others. This is a general definition. Like one example, traffic signals. So in traffic signals, red signals conveys the one information, that information is stop, and green signal conveys the one information, that information is go. So these two signals conveys the information is one is stop and another is a go. This is nothing but one signal here. That's why the definition is which conveys the information. Now here we have to discuss a mathematical definition. The mathematical definition explains a function is changing with respect to time, because according to the mathematical analysis, every function is defined with two variables here. One is a independent variable and another is a dependent variable. Now here we have to take a independent variable should be time and dependent variable is a function. That is like this. See, one variable is here dependent variable, y-axis variable, and x-axis variable should be independent variable. This variable, now I am assuming this is time. So the name of the function is I am taking here voltage. So V of t I am writing now. So V of t, this voltage is changing with respect to time. The changing is like this, sinusoidally increasing and decreasing. This is one signal. So according to the mathematical analysis, this explains the name of the function. So this function is changing with respect to time. The changing analysis is exactly sinusoidal shape here. So this is one signal. So now the name of the signal is always we have to write like this, x of t. Here this x function explains the name of the function. So name of the function is changing with respect to time. Similarly, voltage is changing with respect to time, V of t. Current is changing with respect to time, this is I of t. So always we have to write here, function name is a function name and a independent variable. So the representation is like this here. This function name is changes, but this variable should be always same. Now the mathematical definition is the function is varies with respect to time. A function is varies with respect to time. A voltage is changing with respect to time. The changing is sinusoidal. This is one signal example of this signal here. This gives the example and this is definition. And now here we have to discuss the basic signals. Basic signals. The basic signals are step signal, ramp signal, impulse signal and parabolic signals. Now from this first we will go through the step signal. Step signal. See, the name explains here. The shape of the signal is a step shape here. That's why the name is given here, step signal. The representation is like this. One is a dependent variable, independent variable. This name, now I am writing x of t. So with respect to time axis, initially the function is 0. At exactly t is equal to 0, suddenly increases and it maintains a constant. Now the shape of the signal is step signal, step shape. So the name of the signal is here step signal, and this constant value is A. See, in this graphical representation, this side explains the negative time axis, and this explains the positive time axis. If time is negative, time is 0, that amplitude is 0. If time is positive, amplitude is constant. So this function is changing like this, initially 0 and suddenly increases and constant. So this signal is step signal. This representation is also called as graphical representation, because everything is explained with y-axis and x-axis representation. In the same signal, now we have to write a functional representation. Functional representation explains, this is one function x of t. This function has constant amplitude. This amplitude is t is from 0 to infinity. So t is greater than or equal to 0. And this side, negative time axis, function is not defined. So equal to 0 for t is less than the 0. So this type of representation is called functional representation. This is functional representation, and this gives the graphical representation. So for every signal we have to discuss here these two types of analysis, like one is a graphical and another is a functional representation. Graphical representation is explained with y-axis and x-axis, and functional representation directly it gives the one equation like this. So x of t function is constant amplitude for t greater than or equal to 0. So this total positive side constant amplitude, and negative side that amplitude is 0, t is less than the 0. This is one basic signal. The signal is a step signal.